So, Chapter 11, Conic sections. Conic section means sections of a cone, cross section of a cone. Here we consider hollow cones. So the cross sections are curves, particular types of curves. Now what is a cone? Cone is a surface. It is generated by a line in connection with a particular fixed line. For example, consider a horizontal or a vertical line or a inclined line, a fixed line. Consider a fixed line. Suppose we consider a vertical fixed line. A vertical fixed line. And consider another line which is inclined to this line cutting at a particular point. So consider this. Another line meeting the first vertical line, fixed line at this point, say V. And now suppose the inclined line is rotated around this fixed vertical line. This inclined line is rotated around this vertical fixed line. Then we get a surface, and that surface is called a cone. Rotated, we get this surface. And this is a hollow cone, because the rotating part is a line, so we get a hollow cone. This fixed line is called the axis of the cone. This cone has two portions, an upper portion and also a lower portion, separated by this fixed point, meeting point. And these separate portions are called naps of the whole cone. And then this is fixed line is the axis. This is axis. Axis. And this rotating line is called the generator. That is, the cone is generated by that line, rotating line. It is the generator. And this fixed point V is called the vertex. Vertex of the cone. So a cone has these three quantities. One, a fixed line called axis, a rotating line, a generator, and this meeting point. That point divides the whole cone into two parts, two naps. So the vertex. Vertex. So this is a cone. And now the cross section of this cone. This cross section is obtained by cutting this cone with a plane. So consider a plane, and suppose this plane cuts this cone. So this plane can cut this cone in different forms. If the plane cuts this cone horizontally, then we get the cross section as a circle. Horizontally, then we get the cross section. Cut and look at the cross section. It is a circle. And suppose the plane cut in this form, like this. Then the cross section will be of this form, and this is called a parabola. This form, this curve is called a parabola. And suppose it is the cone is cut by the plane in this form. It is the plane cutting in this form. Then the cross section, you look at the cross section will be an elongated circle in this form. In this form. This is called an ellipse. Ellipse. And suppose the plane cuts the chord in this way, vertically. Then the cross section will be like this, and this is called a hyperbola. Hyperbola. So these are the four various forms of the cross sections or the conic sections: circle, parabola, ellipse, hyperbola. Four different forms. And now these are all curves. Circle, parabola, ellipse, hyperbola are all curves. We can consider these curves as curves in a plane. Or if these cross sections are visualized in a plane, then these are curves in the plane. And then we can have equations of these curves. And also certain related results of these curves. Various results. Like in the case of straight line, we have seen in the previous chapter. Equation of straight line. Then certain properties of lines. Similarly, we can have equations for these curves: circle, parabola, ellipse, hyperbola, and also certain related results. So we will discuss all these in this chapter. Okay? We can have the definition of particular cross sections. This particular cross section, this is called a circle. This is a cross section of this conic section, but this particular form is a circle. This is ellipse, this is parabola, this is hyperbola. And this form can be defined in another form also. You have seen circle in the earlier classes. This circle can be considered as continuous collection of points which are at a fixed distance from a fixed point in a plane. The fixed point is the center of the circle and the fixed distance is the radius of the circle. So in that way we can define, and defining the circle in that way, it is easy to find, or it is easy to derive its equation. Okay. Similarly, other conic sections. So we will have separate definitions for these curves, conic sections, and we derive equations, particularly special types of equations or equations of special type of conic sections, and these equations are known as the standard equations. Standard equation for parabola, ellipse, hyperbola, and also for this curve, circle. Okay, so those can be discussed in the next video. Okay.